Okay, so in this video we're going to take other subjects, other basic components of Python, and so we're going to be looking at primitives. We're going to be looking a little bit about data structures, but not yet with a lot of detail, and we're going to see a lot of operations, math operations that we can do with our primitives. Okay, we're also going to be checking logical operators and string operators. Okay, so what are the basic primitives of Python? We can start this by recalling what in a programming language means to be primitives, and that is basically the types that are int, the types that are float, and the types that are double, perhaps if you are familiarized with C++. You have to remember that an int is a variable that takes some certain number of bits and represents an integer number. For example, we can declare a variable that's going to be named a, and that's going to be equal to 15. So we can use the command type in order to check what kind of primitive is our variable a, and we can see that it belongs to a class that is int. Okay, so that is the basic primitive that you can see. Now we can check the float and the double primitives, and for that we're going to declare another variable, and that's going to be 15.5. okay, now if we write type of b, that's a float number. Now you have to remember that there are two types of float representations, one that is single precision and double precision variables, and single precision variables use 32 bits. Meanwhile, double precision variables use 64 bits. Okay, so to demonstrate this, we're going to import this library that is really important for the development in Python, and it's called NumPy. Okay, you can find online how to install this. You can use the pip command. It is very easy to install, and basically it allows you to work with matrices. So if you are familiarized with perhaps MATLAB, you're going to like this very much, because in NumPy you manage everything as an array. Okay, and so to give a quick example, we can create a variable that's named c, and we're going to create an array using the library NumPy, and we're going to declare this as np.float 32 bits. Okay, so if now we check the type of our array, which is named c, we can see that it belongs to a numpy in the array, and c.the type is the type means the kind of primitive that we're using. The number of bits that we are using to represent our variable. In the case of int, we might be using only 16 or 32 bits. In this case, we're using a single precision float number, or a single precision float number of 32 bits, and we can also declare another variables such as np.array, and it doesn't matter what kind of variable we're using, np.float 64, and then if we print type d, then we have that it is an numpy array, and if we place d.the type, then we can see that it has 64 bits and it is of type float, which means that it is double precision. So those are the basics with the type of the number of bits that you use to represent one of your variables. Whether they are continuous or they are discrete. I might have jumped a little bit longer using arrays, because that's a type of data structure that we're going to see later, but you need to understand this very well. For example, when you're working with computer vision, you may require for some operations 64 bits, double precision numbers for your operators, for your high pass filters, for edge detection, and other stuff. But that is the basics with primitive types in Python. And after that, why don't we go just to look at what strings are. And for that, I'm going to show you something, and this is the way in which you can make comments. Okay, so if you use the hashtag, you can make comments and nothing will happen. It will detect as a comment. Okay, so another way to do that is to use triple. Oh my god, I forgot the name of the symbol, but triple of this symbol, and inside you can place a comment. Okay, and that's going to be a comment as well. In this case, Python has detected it to be a string because of the way in which the symbols are used, but in a program you can use this triple symbol in order to place a comment. Okay, so now we just move to strings. In the strings, we're going to declare a variable that's going to be named line, and inside we're going to place quotation mark. No, I think it's quotation marks. By the way, in Python, it doesn't matter if you use this or these symbols for strings. They are just the same. So we can say I love cats, and we can say line 1 that is equal to I love cats. Okay, so both are the same, equal line 1, and you can see that both represent a string of the same type. Okay, so we're going to place to use our command type line, and there you have it's of type string. And if we use line dot the type, we're going to get an error because it doesn't have a numeric it has a numeric way to represent the number of bits that this variable is using, but you don't have to look at this in this way. Okay, so you have to remember that whenever you're using strings, you're basically using the ASCII code. So remember the ASCII code. It is an 8-bit representation of all the characters that you can that English, Spanish, and some other languages use. So for example, if you say that this is A has a numerical value, an 8-bit numerical variable that represents this A. Okay, and so you can think a string of an array of 8-bit representations that denote some symbol. So in the case of our variable line that you can see over here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 single value variables coded in 8 bits, where I represents a value in the 8-bit notation, space represents another value, and so on. And each of those symbols are coded using 8 bits. Okay, so that is the basics of strings. And if we are working with math operation, now we're going to start working with the operators that we can use with our primitive types. So basically you can use basic summations such as 15 plus 12, that's equal to 27, and you can also code this these numbers into variables. So if you use a times a plus b, then you get 27, and c is equal to a plus b, and then you get c, which is 27, parentheses that is equal to 27. You can do the same, for example, using subtraction, and then there you have what is the subtraction between 15 minus 12, that is 3. For example, what if we want to do this? There you have, and then you have a negative number, of course, because you're subtracting 12 minus 15, and you can actually do this as well. In the print statement, you can put the operations that you want to do with your primitive types. So for example, a times b, 15 times 12, that's 180, and you can divide this as well. Okay, now here's a very important thing about perhaps you're using Python 2.7, and Python 2.7 and Python 3 have a difference in the way that divisions are performed. Okay, so for example, for this, let me open a console that uses Python 2.7. So we're going to use another console, and to open it, we will need to go to the directory of Python 27, and we will have to execute Python there. Oh crap. Okay, Python dot x. Come on. Where is Python? Oh my god. The problem is that as I have this as an environmental variable, okay, I remember now, I use py for the environmental variable, and then you have Python 2.7 here. Okay, so now the differentiation for the division. If you use 3 divided between 5, you get a floor rounded division. It is not using what would you define as a float number. So to solve this issue of the float division, you just have to use or to put one of the variables in float format so that you don't have the rounded division. Okay, and this works for both variables and you get the same result. This is only in Python 2.7, but in Python 3.5 it doesn't matter if you use 3 divided between 5. Both are integer, but it doesn't perform the float division, and it just gets you the float value that you need. And it's the same. For example, I am really used to define one of the variables as float and then perform the division, but it's the same basically. And if you want to perform float division in Python 3.5, you just use double slash and you're going to get the float division that you require. Okay, so that's it with that, and now we can move to work with more complex operations. And for that, we're going to import the library math, and I'm going to show you a command that basically tells you what type of functions or methods you can use with one variable that you are working with. In this case, we have imported a variable which is named math, and so if we use this command, it tells us in the form of a list all the operations that we can do with our library. Okay, so for example, we're going to use math.logarithm. Here it is logarithm. So as you can see, it should work, and if we place logarithm of 1, we get that 0. Okay, and for example, we can use others, math.bow, and this is another way to make exponentials. Oh my god, math.bow, and there you have it. You can make exponentials, but you have to give 2 arguments to the function. So if you say 2, that is 2 power 3, that's 8. Okay, I'm not really used to this way, so the way that I do this is that I use double multiplication symbol, and if you do that, you're going to get the exponential that you require. Okay, and for example, if you want to use the constant e, you just place math.e, and that's going to be your number, and you square this and you're going to have the result, and so you can place it in a variable, and then you can use type r, which is going to be a float, and r.d type, oh my god, d type, oh my god. Okay, so we know that this is a float, but it doesn't work in this way. But the idea is that the math library is going to give you a lot of operations so that you can perform math operations, and you can use the dir command to get the operations that you require in that case. Okay, for example, math.sqrt of 4, that's going to be 2, and you can explore other variables or other functions that you like or that you require for the programs that you're writing. Okay, so that's another way. And okay, so my cat requires some attention. Oh, okay. So continuing with this, we can now work with operations using the string primitives that we have learned before. And for that, I'm going to show you a simple way to concatenate the strings. And so look at this line, and we're going to say Rodrigo plus Lopes cats. Okay, so we're going to put a space here, and there you have it. You have a very simple way to concatenate strings. It's just like in Java, very easy to do. So we can use variables for this. So Rodrigo, and I know likes, loves cats. Okay, so we say name plus likes, and we're going to get the 2 words that are going to be joined, but we don't like that, so we can use name plus space plus, oh come on, plus likes, and there you have it. Okay, so there's a way to concatenate strings. And the next operation that we can do, and this is a very interesting operation because it uses logical operators, is, for example, you can use AC in ACTTG HGGT CCC. Okay, so this is a very interesting thing because you can detect if you have some sort of pattern inside of another text or sentence or whatever you're working on. So this is very useful for bioinformatics, for example, and you can detect this pattern of AC in this gene string that you have coded from some bacteria or something that you're working with. Okay, but you can use it in other things such as spam detection. For example, you're working for the word you in, and for example we're going to declare this line as and we're going to define here an email. Okay, so dear Rodrigo, you have been chosen for a great chance to study abroad. You are the only one that has been chosen. Okay, so of course that is spam, and we can detect the word you appears in this text. Okay, in a very simple way because we can store this in a variable. Okay, and you have a binary representation of what your pattern means at least. So that is a very interesting thing to work with your strings. And now we're going to make a little bit more of things that might be useful for you. And so we're going to say Rodrigo is really great. Well, I'm not a teen anymore, young adult, I guess. So line.count, and here we're going to use Rodrigo. Okay, so this is another function that you can use with your strings. You can use the function count, and that's going to return you the number of times that this pattern appears in your string. So for example, line.count, and we're going to count this time not a word but a single letter, for example the letter O, and there you have 1, 2, and where's the other one? 3. Okay, so it's going to return you the account of the words that you have in a very easy way. And I was forgetting, you can also do this. For example, you have defined your variable line to be a string, so we can use the dir command in order to show all the embedded methods that we can use with this primitive. So for example, you can use rsplit, we can use split lines, starts with. So for example, line dot starts with, and we're going to give this a true statement. So oh my god, starts with R, and that is true because we're starting with R. Of course this is going to be false because the R in which we are starting with is not capital, and so you can use that. You can use another one which is upper. Come on, I hate Spanish keyboards. Okay, that's it. You can also use I don't know which one is also interesting. Upper rsplit strip. This is interesting, so we're going to define another one. Look at the way that I'm placing spaces in the variable. So here you have 3 spaces, and here you have another 3 spaces, right? So if we just use the len method with our variable string line, then we get 11 spaces, and that's because of the length of Rodrigo plus the 6 spaces that are in each of the sites. And in order to avoid that, because whenever you're working with web scrapping or things like that, you're going to need to get rid of that, and in order to do that, you can just use strip, and you're going to eliminate the spaces that you have in your variable. Okay, so there you have it with space, and if you just use strip, you're going to eliminate all the spaces. So that is the things that you can do, some of the things that you can do with your strings. Now finally, I'm going to show you another thing that you can do with your strings, and it is slicing. And the slicing operators are very simple to do and are very useful. For example, we have this line, but we're going to strip. We're going to shorten it because I don't like to have those spaces. We're going to print the line, and there you have it. And now we're going to slide the string. Okay, so how do we slice this? You're going to use semicolon to denote the number of to denote the index that you want your string to appear. For example, we want from 0 to 1, and we're going to get R. If we want from 0 to 5, we're going to get Rodri, and we're going to avoid the last two characters. If we just use 6, we're going to get Rodrigue, and 7 of course is going to display the whole name. If you want to display the whole thing, you just use semicolon inside, and you can also take small parts. For example, you can use from 5 to 7 to get the last two characters, and so on. Okay, so remember that the first one is the one in which you're going to be starting with. For example, 5, this is 0, 1, 2, 3, 4, 5 until 7. 7 of course doesn't exist, so it's 6, 7, and it's going to show until the previous one of the number that you have placed in after the semicolon. Okay, now another very interesting notation that is not really useful, but a lot of people like to play with, is that you can use also negative numbers to index your string. So in this case, if you just, and I'm going to show you this in a way that you can understand, so it is very easy. So look at this pattern. Okay, so you have to know that -1 represents the last letter of your string, -2 represents the letter previous to the last one, and so on. Okay, so that is the way in which you can slice your string using negative operators. For example, from -1 to -3, you're going to get come on, from -3 to -1, you're going to get those characters from your string. Okay, so people don't use this, but I don't know, I think there is a reason why they created this. But that is basically the things that you can do. And to finish with this video, I'm going to show you a little bit about Boolean operators. So we're going to declare a Boolean, and B that is going to be false. Remember that in Python you have to use capital letters at the beginning of true and false. And now what we can do is some logical operators, or XOR, and NAND, and others. So for example, A or B, of course that's going to be true. A and B, of course that is going to be negative or false. And some other operators such as XOR. Okay, I don't remember. I think that in Python 3 it is different to use the XOR, but you get the idea. Just look at the documentation, and we can actually do this. Okay, so here we have the okay, AR XOR V. Oh, come on. Okay, it doesn't matter. Look at the documentation. You cannot see it from here. But that is basically the things that you can do. Remember that you can detect patterns using strings. You can use basic math operations using your primitives, and you can even apply logical operations using strings or primitive types, or as you have seen, booleans. Okay, so that's it for this. In the next one, we're looking at data structures.